we would like to find the center and radius of the circle of curvature of the spiral helix 4t, 5 sine 2t, 5 cosine 2t at the point pi 5, 0. So we have been working with this helix in the past several videos, and we know that at this point the time is pi over 4 by just solving the equation 4t equals pi. And we've also studied it to the point where we know the curvature at any point on this helix is 5 over 29. The spiral helix here has constant curvature, and the curvature kappa is 5 over 29. So when you have a curve and a point, then not only is there a tangent vector at that point, but there's also a circle that most closely resembles the curve. So in the sense that the circle has the same tangent vector as the curve at the point of tangency. And that circle is also on the same side of the curve as the normal vector. So this one is t, the tangent vector, and this one is n, the normal vector. So the circle has a radius equal to 1 over the curvature. So that's 29 over 5 for the radius of our circle. And now we want to know the center of the circle. The normal vector 0, -1, 0 has magnitude 1. And so if we just take this point, so to find the center, we will just go from this point in the direction of n, this distance, because the radius would be that distance. This one is the point pi 5, 0, and this point we want to figure it out, but it's along the vector n. It's a point on this vector if we write the vector emanating from pi 5, 0. So the center will be pi 5, 0, which I'll write in vector form, plus this distance, 29 over 5, times this normal vector, n. So in other words, pi 5, 0 plus 29 over 5 times 0, -1, 0. So that's going to be pi, and then 5 minus 29 over 5, and then 0. And this is -4/5. So we have pi -4/5, 0. So the center as a point is the point pi -4/5, 0. Just putting this back in point form. So there's our center of our osculating circle, also called the circle of curvature. The osculating circle, and the center is pi -4/5, 0, and the radius is 29 over 5. So that describes the circle.